Hey everyone, can you hear me in the back? Yeah, I'm not 100% you can see me, but hopefully you can see me. Hopefully you can hear me. So I'm Jenna, thank you so much for having me today. I'm a developer based out of Toronto, Canada. And yeah, my first time in Taiwan, I've had a really awesome time so far. I work at a company called Shopify, which is a commerce platform for selling online or in person. Over the last couple of years, I've worked on our sales channel integrations with things like Amazon and Google and Facebook. And most recently, I've been working on the Shopify Fulfillment Network, which provides shipping and logistics services to our merchants. So if you're interested in Shopify or any of those things, come talk to me afterwards. So today I'm going to be giving a gentle introduction to event sourcing. So we'll talk about what event sourcing is and what kind of issues it's trying to address. We'll talk about the key components that make up an event source system, and then we'll dive into an example using Ruby. So my goal here isn't to sell you on event sourcing or to claim that it's a silver bullet that will solve all of your problems, but just a way to think about your data in maybe a different way than what you're typically used to. So before we get into event sourcing, let's talk about how we typically design our systems using a really simple database-backed web application. So we're all pretty familiar with a user account. In our example, our accounts have an email address. We track whether our accounts are active or not. Maybe we have different plan tiers that we offer our users, and we store some timestamps. So let's take a look at some of the typical lifecycle events that we associate with these account models. So when they first sign up for our service, we want to register them. So we create a brand new record in the database, and we set the isActive attribute to true. Then they decide to upgrade their plan. Great. So we take all their banking information, we probably store it somewhere else, and we upgrade that plan tier attribute to paid. Then a couple of months go by, everything was great until their banking information is no longer valid and we have to disable their account. They go back in, they fix the issues, we re-register them, we find their account, and we set that isActive attribute back to true. And then they decide that they want to stop using our service, so we disable their account on purpose this time. So the point that I'm trying to make as we go through these examples, these lifecycle events, is that every time we do an update, we are getting rid of some of the data that describe the history of that account and how it got into its current state. So after the banking information was invalidated and after our user manually disabled their account, our database looked exactly the same. So we've lost a lot of context about how that record arrived in its current state. So we're all familiar, we use a lot of different mitigation strategies to compensate for this data loss. We add lots of logging and we pump all of our logs into queryable systems that we can use to try to retrace what happened. We sometimes add more columns to try to contextualize our data. Sometimes we go even further and we store every single change to our records as their own record so that we have a snapshot of the history after every change happened. But in each of these mitigation strategies, we're still missing some key bits of information. We still don't really know why the state changed, so the business logic that caused our record to change from A to B is lost. So what we end up doing is we look at our code and we look at our database side by side, maybe with one of these other data sources, and we try to piece together what happened. And as we know, as an application grows in size, the number of different ways that a record could arrive in any given state grows as well. And so this is the particular issue that event sourcing is trying to address. In this architecture, the business process itself, the thing that caused the record to change states, that is the thing that we are persisting. And we can arrive at our application's current state by replaying all of these events one after another. And so some argue that event sourcing is perhaps a more realistic way to model tangible real-world business processes, because in the real world, something happens that causes a change, and our database record, as we typically think about it, is really just an artifact of that change. So what does it mean to instead think of our event as a first-class citizen in our application? So we need our events to contain all the information needed to change from one state to another. Our events are immutable and append only, which means if you make a mistake or there's an error, you actually have to create another event that will revert that change rather than going in and editing that event. And our current state is completely disposable, so we can recreate current state using our persisted events. And so what it also provides you is an opportunity to also start building a universal language if you work with an interdisciplinary team. So instead of talking to your designers or your domain experts or anyone else in your company about some state in a database somewhere and how that is affecting maybe the user experience, you can frame your discussions around these events in a way that actually can help you improve some of your domain modeling. Okay, so before we go into the other components that make up an event source system, I need a bit of an interlude to talk about CQRS. So CQRS stands for the Command Query Responsibility Segregation Principle, which on its own would take an entire presentation to discuss, but the main takeaway for CQRS is it can be highly valuable to separate the read side from the write side of your applications, and building a mental model for separating these two sides helps to understand some of the patterns that event sourcing builds upon. And so the reason that it can be valuable to separate the read and write side of your application is really so that you can scale and operate them independently. So while your write side might care about things like data integrity, maybe optimizing inserts or updates, your read side can care solely about making really efficient queries available, maybe denormalizing some data so that it is appropriate for some of your views. But as you can imagine, if you're not reading and writing to the same place, it can make the flow of data a little bit more complicated. So let's take a look at the data flows in our typical system so that we can contrast it with an event source system. So with a client, our client can make a request. It will likely get routed to the correct model or service that is able to handle that request. Maybe it'll be validated, and if it passes, we'll go out and we'll do some stuff. Maybe we will make a record of it in a database somewhere, and then we'll send a response back to the client. The client might also query our application for some data that it might need, and the domain model might also be responsible for shaping that data appropriately and sending it back as a response to our client. So what does the flow of data look like in an event-sourced architecture? So I'm going to introduce a few new terms, which I promise I'll go back and define more in depth afterwards, but I think it helps to see how all of the components fit together. So when we're starting with our client issues a command, and the command communicates intent. What is the client trying to do? The command will be validated against our domain model, and our domain model are kind of the nouns of our system, so our products, our orders, whatever. If that command is accepted, it will become an event. An event is what we persist in event store, some kind of persistent storage. And the events from the event store can be replayed one after another against the domain model to create a customized projection. And the projection is the thing that our client can query against to get current state. And the thing that is interesting, because we are separating our read and write side, our projections can be pretty independent from our domain model. So we don't need that one-to-one object table mapping that we're used to. So it doesn't need to care about data validations or even have the same schema as our domain model. So it can be optimized specifically for whatever the client needs to query. So just to go over some of those new terms, we have a command, which is initiated by a client. It communicates intent, and most importantly, it can be rejected. Then we have our domain models, which are our nouns, and the things that hold our business logic. You'll also sometimes hear this referred to as an aggregate. If you read more about event sourcing, that basically just refers to maybe like a collection of domain models that are treated kind of as a single entity. So an example I like to think of is an order that has many line items in the order. You generally don't want to manipulate your line items directly. You want to be able to manipulate your entity as a whole. Events, as we defined before, contain all the information needed to change state, and our events are append-only. And our projections is that read-only side of our system that can provide the client with the current state of the application. You can imagine the event store is not really suitable for presenting current state. If we have a ton of events, it would be pretty expensive to have to replay them all when any request comes in. So we create our projections that are customized for our clients to query. And we can create as many projections as we want, and we can update our projections as frequently as we see fit. So for some things, we might need to update our projections as every event occurs. But for other things, let's say we have like a weekly sales report, maybe we can update that less frequently and use batching to update or to optimize performance. Okay, so the next thing we're going to do is walk through an example. So what I'm going to do is start with a really simple account model with the lifecycle methods that I described earlier. And what we're going to do is see how we would incrementally start to apply some of the ideas of event sourcing into our example. So if you're looking to bring in some of the benefits of event sourcing, but you don't have the time or the resources for a full rewrite, hopefully you'll get some ideas out of this. Okay, so we have our account class. Here we're assuming we have a simple web application, active record is our ORM, and we're defining those 3 lifecycle methods that I walked through at the beginning. So we have our register method, which ensures an email is supplied before we set the account to active. We have change plan, which sets the plan tier on the account and holds some of the business logic around how our users can transition their plans. And disable, which kicks off a job to send an email to our users only if they disabled their account manually. Okay, so let's zoom in on this register method. If we look closely, we already have some of the components of an event-sourced architecture that I introduced earlier. We have a command, it's called register. Before we do anything, we perform some validations against the domain model. And if those validations pass, we do some stuff. And so I said we're going to move towards an event source system incrementally, and the first step is purely cosmetic. We're going to wrap all of this stuff into something, and we're going to give that something a name. This stuff is our event. And that event is account registered. It fully describes our state change, and semantically, this is how we would describe it in real life. The account was registered. So we'll do the same thing with account disabled and plan changed. So we've given our events some names, and we've described how the events get validated and applied against our domain model. But what I said before was that an event should contain all of the information needed to change from one state to another. And so given an event, we should be able to figure out exactly what in our system was affected and how. So clearly this thing that we've labeled as an event isn't really enough. So we're going to replace this parameter with a more data-rich object. Okay, so we have this plan changed event object that we've replaced our parameter with, and it's just a plain old Ruby object. It's initialized with some reference information about the domain model, along with the data that we'll need to actually update our object with the event, and we'll also include some historical context about the state that the object was in before the event was applied. And again, so far the changes that we've made have been purely cosmetic. We haven't actually changed any functionality. So what we're going to do next is add some code that will help us push the event into some persistent storage, and also some code that will allow us to retrieve our events and rebuild our current state from them. So in order to do that, we're going to replace these methods that were being called to handle the events with a bit more of a consistent interface. And this interface will just allow us to persist and retrieve events using the same code everywhere, regardless of the specific event or the domain model itself. Okay, so I'm going to define this new method apply in this builds object class, which will include in any object or any class that we want to be able to build from events. And apply is going to do two things. It's going to handle the event, meaning bring the object up to date by applying the change described in the event, and then publish the event. So handle will just ask the event for a method that knows how to handle the event, and it will call it with the event as an argument. And the domain model is still responsible for describing how events are handled, which kind of makes sense. Our domain models are describing our business logic, how our system should behave, so it makes sense that it is still responsible for describing how events are handled. And publish, second step in our apply method, is going to save the event to our event store, only if it's a new event. And we'll talk about the times that we have events in our system that are not new events in a little bit. Okay, so let's dig into what this event store is doing. I know that some of you probably can't see the bottom, so it'll be available later. Okay, so we're going to look at the event store class. So what I'm doing here with the event store class is really just to show you what the interface of an event repository might look like and how you might interact with it. So under the hood, we could be using MySQL with an append-only configuration to store our events. We could be using Kafka, RabbitMQ, Redis, each data stores with their own pros and cons. But if we understand the whole concept and we create the right abstractions, the implementation details of what we are actually using to persist our events shouldn't really matter. We should be able to swap one out for another depending on our needs. So in this example, we're using a simple in-memory event store. So we're holding on to our events in a hash, the key being the object's unique identifier, and it points to an array of events. So when we call save, we'll look into our event store to see if we already have some events that are using that object reference ID. And if we don't find any, we'll assign an empty array. Then we will append our new event and we'll assign it back to the correct key in the hash. Okay, so what about rebuilding the object from our events? So we'll always start with a new instance of the object and assign a unique identifier if it's given. We'll find all of the events that are associated with that identifier, and then if they exist, we will rebuild the object from those events. You can imagine if we have no identifier or no events, we're simply initializing our object. Okay, so let's dig into what this rebuild method is doing. So rebuild will go through every event and call apply, that method that we defined before for handling new commands. But here the isNewEvent flag is going to be false. This is so that we don't save it again in our event store. And also, if we have any listeners or subscribers to the event, we want them to know whether this is a new event or if it's just being replayed from our event store. Okay, so that's kind of a new term, subscribers, which I kind of left out of my original diagram just to keep it simple. But a subscriber is just any other part of our system that wants to be notified when an event is published. And we kind of sort of already introduced subscribers, so in order for us to be able to build those customized projections, we need some kind of mechanism of knowing that an event was just published so that we can update our projections accordingly. So sometimes you'll hear this kind of subscriber being referred to as a projector, which is really just a kind of subscriber that is responsible for building and maintaining those projections for our clients to query. So the other kind of subscriber in our system is a reactor, which rather than keeping projections up to date, is basically responsible for everything else. So it could be updating some external system, maybe gathering some data from an API, kicking off kind of any other work that might in turn also cause other events to occur. But you can think of projectors and reactors as essentially the same. They both subscribe to particular events and trigger some kind of action in response. Okay, so to implement this, we're going to go back to the publish step in our base object, and we'll add this new call to notify our subscribers. So in this example, we just have our subscribers statically defined. So similar to the event store, there's lots of different tools out there for creating pub subsystems, but the idea here is not to get particularly attached to a technology or implementation, but just to build up that mental model of all of these components that make up an event source system. So when an event is published, we're going to broadcast the event to all subscribers in our system. And the subscribers themselves are going to be responsible individually for choosing whether to act on or to ignore the event, depending on maybe the event type or maybe some of the parameters associated with the event. Okay, so let's look at one of the examples of one of the subscribers in our system. So the disabled account email sender, which handles sending out that email if a user deactivated their account manually. You can see that it defines what kinds of events it listens to, if it cares about new events only, maybe it looks at some of the metadata associated with the event, and then it kicks off whatever work needs to be done. So you can imagine if we have different parts of our system that each care that this event was just published, we could implement individual reactors that each have their own business logic around what they need to do and what kinds of event state they look at to each build up their own workflows. And you can also tell that if we were just replaying our events from our event store, we want to be really careful that we're not sending out those emails. Okay, so let's take a closer look at how we would build our projections from the event stream. So recall, in order to query for current state, it would be pretty expensive to read out all of our events from the event store. So we build these customized projections that our clients can query. So in this example, let's say we need to build an internal UI page that just shows all of the active accounts in our system. So similarly to the email sender, our projector will be listening to our event stream, and in response to particular events, we'll update our projections accordingly. Unfortunately, at this point, we're running into a bit of a naming collision when we want to create this particular projection. Because, as I said before, we were moving towards event sourcing incrementally, and so far we've been using a single class to represent our domain object, as well as this class that we just added, which is kind of representing or creating our read-only projection. So at this point, we do have to do some renaming so that we have one class that represents our domain model, which is like the C of CQRS, from the query side. So because the domain model now does not interact with the database directly, it can also just be a plain old Ruby object, and we can create classes that inherit from Active Record to represent our view objects if we want to use Active Record as our ORM. And so now we have one object that's handling our commands and our domain validations, and another object that is handling our queries. And we can create as many of these as we want. Maybe we have some that, again, don't conform to our domain model schema or some of the validations that we've associated with our domain model. So perhaps we have fields that we require of our domain model, but for particular views, we don't need to include them. Okay, so we are almost there. The last thing we need to talk about is commands. So instead of defining these methods directly in our domain model, these things that are sort of defining the client intentions in our system, we're going to pull them out and put them into their own classes. The reason for this is really so that we can keep our domain model purely about our business rules and not necessarily worried about managing and orchestrating the sort of command, validate, event production logic in our system. So our command is going to be initialized with some arguments coming from the client and call whatever validations that it needs to perform against the domain model. And then we'll handle the command by first rebuilding the account to current state and then apply the event. Okay, that was a lot. Let's recap. What was easy? So we have a new way of isolating and modeling the business logic in our system in a way that perhaps some argue better represents the real world. We have this new universal language for communicating with an interdisciplinary team. We have the ability to scale the read and write side of our application without tight coupling. And we get things like historical traceability and auditability for free. So what's hard? There's a lot of new things in our system and a lot of new things that we have to give names to. And at the beginning, especially, there's a lot more work for implementing even very simple logic. So in our example, we started literally with one class that we read and wrote directly with, and it spawned about like 5 or 10 classes that we needed to implement basically the same thing. Handling schema changes can be difficult. We know that in our applications, nothing remains static. Some business rules might change. We might find an error that we need to handle. And so if we have these immutable events in our system, we need a way to handle these events that maybe don't conform to these upstream changes that we've made. So some ways that people have come up with to deal with these issues are versioning events, or putting in specific event handlers that specifically handle backwards compatibility. So let's say a field is required and maybe it's missing in our previous events, kind of putting in this like a bit of a monkey patch to make sure that if the field isn't there, there's some way around it. We have to compensate for the eventual consistency nature of our system. So as I said, we're not reading and writing to the same place. So when we write to our data store, it might not be immediately available, and it will depend how quickly we are updating our projections. So an example that could be challenging is, like, what if we had to implement unique email addresses? So the way we typically design systems, that would be pretty easy. And so an event source system, we could perhaps get this information from querying our projection, but it could be stale depending on how fast we're updating our projections. So we could pull all of our data from our event stream for all of our different records. That would probably be pretty slow. So different business requirements and different risk tolerances for stale data will call for different compensation techniques. Okay, so my talk title was a little bit deceiving. Event sourcing isn't really for everyone, and it's definitely not for every app, but it does address some common concerns that exist in applications as they mature and become more complex. So thank you very much for your time. I have all of the example code on GitHub, as well as links to a bunch of resources that I used when I was preparing for this talk. So example apps, frameworks, other talks. So yeah, I learned a lot. So thanks to all those people that put their information online. So thank you.
It's now our Q&A session. Any questions for Jenna about event sourcing? Yes.
Oh, thank you for your presentation. It was really great. I was wondering, is there any type of like scaling issue when it comes to, you have to take all those events and then basically merge them together to figure out what the actual state of the record is?
Yeah.
Does that introduce any scaling problems, or how do you deal with those?
Yeah, so one of the techniques that people have come up with to deal with that is snapshotting. So it's kind of like cache invalidation. You have to decide when is a good time to snapshot your data. But if you have your event stream at a certain point, you can say, okay, I no longer care about the historical record. Like, I don't need every fine-grained detail, and I'm going to basically like compact all those events and then replay all my new events on top of that state. So you end up losing data just as you had before, but you end up with maybe more performant code if you have a ton of events. Yeah.
For
first off, I wanted to say super duper talk. Like, I really, really enjoyed it. It touches on like the subject of domain modeling. For me, as someone who's relatively new to programming, it seems really, really hairy, and this helps me understand it. I'm curious to know, for someone who has more experience than I do, like, obviously this pattern involves adding a lot of complexity to the application. How would you evaluate for a given project that you're working on, whether like the needs of this project warrant this added complexity?
I think that's a good question. I think it depends. Depends how. Okay, so one is like, how bad is it that you're losing all this data? So your bank isn't one line in a database somewhere with like a number constantly changing. Like, they use event sourcing. They get like every debit and credit that you make, they record, and then your current bank account balance is that number like rolled up. So for a bank, they probably want to really make sure that they're not losing every event. For maybe like a social networking site that really only ever presents current state, and maybe you only need the events for debugging, maybe that wouldn't be as worth it. For us, so like at Shopify, we're mostly not using these techniques. There's one or two teams that do sort of some event sourcing style work, but one of the things that was interesting for us was to think about event sourcing as a way to like structure our logs. So at the beginning, for a project I was working on, our logs were just like anything goes. Like, anyone would write anything to the Rails logger, and like you had to have like regex like mastery to find the information you were looking for, and it was just like a waste of time. And so what event sourcing, like these ideas, we didn't change any of our code, but we started thinking about the things in our system as events, and we created like really structured logs that conform to a pretty particular API, and it just made our lives a lot easier when we were talking about, especially when we were talking to people that weren't developers. So we have like lots of different tiers of support, and they're like, this thing is in this state and I can't figure out why. It made it a lot easier to like talk about what went wrong, and it made it a lot easier for us to find what went wrong. I hope that answers your question.
Thank you for your inspiring talk. But one thing I want to ask is, how do we for a product selling, something like stock keeping the stock, like we have or like quota, that kind of application. How do you maintain, like, you don't oversell something? What's your suggestion for this kind of use case? Thank you.
Good question. So that might be a case where you need to make sure that your projections are being updated like immediately after events occur. You might need your commands to like wait until maybe no other requests are issuing the same command. Like, you'd have different techniques for dealing with it depending on how important or how likely those kinds of race conditions are. Some people that are like proponents of event sourcing say that like this is a problem anyways. Like, just because we have database transactions doesn't mean that this doesn't happen. So it's about what window makes sense for having stale data in your system, and coming up with mitigation strategies that make sense depending on your risk tolerance.
Acceptable to lock the projection database thingy?
It wouldn't really help, because you'd still be writing to your event stream and you're reading from your projection. So even though you're locking your projection, your right side is just like, sure, I'm just gonna like push this in. So that's really when people talk about CQRS, like never mind event sourcing, that's a huge question, is like, how fault tolerant is your system for completely separating the read and the write side of your application. So you might gain all of these scaling opportunities, but you might lose some of these like optimistic locking techniques.
Any more questions? Yes.
Do you ever have a situation where you have to delete someone's history upon request? And if that's the case, would this does this make it harder?
I was just reading a really interesting article. I'll try to make sure I add it to the GitHub repo because someone just posted a really interesting article about GDPR and event sourcing. So if you know up front that you might have some PII, like personal identifiable information, you might be able to have like an identifier in your event and then put your PII somewhere else so that it's just like pointing somewhere else, and then you can delete that data upon request. But that only helps if you have like hindsight is 2020. Like that only helps if you know up front. So in that case, like you might have to change your events, like edit your event history, and that, you know, can be a problem. Yeah.
Any more questions? Yes.
This is somewhat related to the first question that was asked. Regarding the event sourcing system that you talked about, there's still a lot of redundancy in there. That is, like, we are applying a lot of events that essentially are being done again and again. So don't you think it would be better to have some sort of a hybrid system where, like, some processes use the event sourcing like the logs, and while the user interface or something that doesn't need an event-based system uses a...
Can I clarify the question? Does it mean like the code we were writing had a lot of duplication, or the actions?
Just the process of applying the events all over again. For any new event, you have to apply all of the old events again. So that just seems that there's a lot of redundant computation being done.
Yeah, so that's where like snapshotting comes into play, where you can say, okay, I don't care about this history, and I'm just gonna apply my new events from the last maybe 3 months. I think if you're not interested in building current state from an event log, then it's probably not the right application for event sourcing.
Yeah, but that also depends on the action that I'm talking about. Like, for example, logs is something that I care about the history. But if I only care about, say, like what is the user's current balance or something, I don't really want to compute that every time I like want to check its balance.
So yeah, so like if you take your bank account as an example, like you as a developer might not care about the history, but like if you have an audit, or if you are a user that wants to see a specific transaction at a point in time, like that might be important to keep around.
Okay.
Yeah, again, like I would say like the idea with this talk isn't to say like event sourcing is the only way to write applications, like go home and change everything. But for me at least, it kind of is a bit of a flip of how we currently think about database state. You know, we kind of think about database state as this like global thing that is always there, and we change as soon as we need something to be different. And we don't really care about the data that was there before. And so this is just a different way of thinking about data in your application.
So do you like completely move to event sourcing, or do you also have a...
I just think it's cool.
Oh, okay. Thank you.
Okay, I think we can take 3 more questions. Anyone?
Not question.
Okay.
Not a question, but the answer to the previous question is, personally, I think event sourcing, like you can both for the bank account example, you're not necessary to replay all the events from the last snapshot of 3 months ago. You can like store every state in the event, so that you can just get the state immediately. I think like you can store both, so performance is not quite impactful. I think just so the performance impact is just one more record for each of the update you send to the database. Yeah,
exactly.
Yeah.
And that's why we have projections.
Okay. So any other questions?